Good morning all of you. Today we are going to discuss some applications of similar triangles through some problems. So exercise 8.1, third sum. In triangle ABC, DE is parallel to AC and DF is parallel to AE. Prove that BF by FA is equals to BE by EC. So, this is triangle ABC and it is given DE is parallel to AC. Given DE is parallel to AC. Therefore, DE divides AB and BC in the same ratio. Since DE is parallel to AC, DE divides the sides AB and BC of triangle ABC divides in the same ratio. That means BD by DA is equals to BE by EC. Since Thales theorem. Similarly, in triangle ABE, DF is parallel to AE. In triangle ABE, DF is parallel to AE. Therefore, BD by DA is equals to BF by FE. Since Thales theorem. Now, from these two equations, we observe LHS BD by DA is equal, therefore RHS is equal. Therefore, BE by EC is equals to BF by FE. Hence, proved. Prove that a line drawn through the midpoint of one side of a triangle parallel to another side bisects third side. This is a triangle ABC. DE is the line drawn through the midpoint of AB parallel to another side bisects the third side. So, given in triangle ABC, D is the midpoint of AB, so that AD is equals to DB. That implies AD by DB is equals to 1. And also DE is parallel to BC. Required to prove line DE bisects the third side AC. Bisects third side AC. So to prove BE bisects third side AC, enough to prove E is the midpoint of AC. If E is the midpoint of AC, then AE is equals to EC. Or if AE is equals to EC, E is the midpoint of AC. Hence, DE bisects AC. Proof. Now, in triangle ABC, DE is drawn parallel to BC. Therefore, by basic proportionality theorem, if a line drawn parallel to one side will divide other two sides in the same ratio. Therefore, AD by DB is equals to AE by EC. Now from 1 and 2, AD by DB is equals to 1. From equations 1 and 2, AE by EC is equals to 1, since AD by DB is equals to 1. So do cross multiply, AE is equals to EC. So if AE is equals to EC, DE bisects AC at E. Therefore, DE bisects AC at the point E. So, in the figure, DE parallel to OQ, DF parallel to OR, show that EF parallel to QR. So, given DE is parallel to OQ and DF parallel to OR, required to prove EF is parallel to QR. Proof. Now, in triangle OPQ, DE parallel to OQ. Therefore, PE by EQ equals to PD by DO. Since basic proportionality theorem, similarly, in triangle OPR, DF parallel to OR. Therefore, PD by DO is equals to PF by FR. Since same basic proportionality theorem. Now from these two, we observe PE by EQ is equals to PD by DO, and again PD by DO equals to PF by FR. Therefore, PE by EQ is equals to PF by FR. Now, observe in the diagram, PE by EQ equals to PF by FR. That means EF divides PQ and PR in the same ratio. Therefore, by converse of basic proportionality theorem, EF is parallel to QR. Hence proved. So in this figure, triangle PQR, A, B and C are the points on OP, OQ and OR respectively, such that AB is parallel to PQ, AC is parallel to PR, show that BC is parallel to QR. So consider triangle OPQ. In triangle OPQ, AB is parallel to BQ. Therefore, OA by AB is equals to OB by BQ. Since Thales theorem or basic proportionality theorem. Similarly, in triangle OPR, AC is parallel to BR. Therefore, OA by AB is equals to OC by CR. Since Thales theorem. Now, from these two equations, we observe LHS is equal, therefore RHS is equal. Therefore, OB by BQ is equals to OC by CR. Now observe this diagram. OB by BQ is equals to OC by CR. We apply. That means BC divides OB, OQ, OR in the same ratio. So in triangle OQR, BC divides OQ and OR in the same ratio. That means we have converse of basic proportionality theorem. That is, if a line divides any two sides in the same ratio, then the line is parallel to third side. So here OB by BQ equals to OC by CR. That means BC divides OQ and OR in the same ratio. Therefore, BC is parallel to QR. Since converse of Thales theorem, hence proved. ABCD is a trapezium in which AB parallel to DC. Is a trapezium, AB parallel to DC, and its diagonals AC, BD intersect at the point O. Then show that AO by BO is equals to CO by DO. Given ABCD is a trapezium in which AB parallel to DC and diagonals intersect each other at O. Required to prove AO by BO is equals to CO by DO. Proof. So to prove AO by BO is equals to CO by DO, through O, draw EF parallel to AB. Through point O, draw EF parallel to AB, so that EF is also parallel to DC. Now, consider triangle ACD. In triangle ACD, EO parallel to DC. Since EF parallel to DC, therefore EO divides AC and AD in the same ratio, that is AO by OC is equals to AE by ED. Since basic proportionality theorem. Now, in triangle ABD, EO parallel to AD. Since EF is parallel to AD, therefore EO divides AD and BD in the same ratio, that is DE by AE. Is equals to DO by OB. Since basic proportionality theorem. Now, here this ratio take inward 10, that means EA by DE is equals to OB by DO. Since inward 10. Now, observe these two ratios. AO by OC equals to AE by ED. Again, AE by ED is equals to OB by DO. That means AO by OC is equals to OB by OD or DO. Now, what we are going to prove? AO by BO is equal to CO by DO. Therefore, interchange these two. That means AO by OB is equal to OC by BO. Therefore, AO by BO is equal to CO by DO. Hence, proof.